We talked briefly about the stack and how it contains stack frames, but what are stack frames? Stack frames are data structures created during program execution to keep track of functional context. Sections of the stack frame are governed by the stack base pointer, or EVP, and the current stack pointer, ESP. Let's say that we have a function called draw an equilateral triangle. A function within the draw a triangle function is draw 3 equal lines, which takes a length as a parameter. After this function finishes, there is another function to print out yay. During the execution of the program, the instruction pointer, or EIP, runs through the commands in the text/code segment, and then it receives the instruction to enter into the function draw 3 equal lines. When this happens, a new stack frame is created. This happens by first setting the stack base pointer, or EBP, to the current stack frame pointer, which rests at the top of the draw an equilateral triangle stack frame. Then, based on the location of the stack base pointer, we push the parameters of the function, in this case a length. And then, the save frame pointer is added, which contains the address of the last stack base pointer. Then the return address for the next code instruction after the function finishes is added. And then the local variables, such as the line width in this case, are tacked on top. Lastly, after all the local variables are accounted for, the ESP pointer is placed at the top of the stack. For this workshop, it's important to be able to identify where the return address and the save frame pointer are located in the stack using a debugger like GDB. When the program finishes drawing 3 equal lines and moves out of this function, it needs to release the stack space. To do so, it will restore the stack base pointer, or EBP, to the value in the save frame pointer. And then EIP will use the stored return address to continue to the next instruction, which, in this case, is in charge of printing out yay. If we assume that printing out yay is its own function as well, we now know that the program will create another stack frame for the print by storing a save frame pointer from the stack base pointer to be used when the function is finished, a return address for EIP to use when the function is done, and the desired print message yay because it was a parameter to the print function. All this setup also pushes the stack pointer ESP higher up. The creation and removal of a stack frame happens whenever we execute a new function. Because the number of functions that a program can use in runtime can be different with each run, the stack is not fixed in size. Lastly, the creation of the stack that I just described is usually what happens. At the same time, that's not always the case. Depending on how your execution system is structured, there can be extra values in the stack frame which are important to execution, among other variations.